do not need your computers right now, so please shut those for me. All right, so just to clarify that a little bit, this is a rational equation. Sorry, messing this up. This is not a rational equation. Okay, rational begins with that word ratio, which should make us think fractions. All right, so we're dealing with equations that have fractions in them, in which we find variables in the denominator. Okay. All right, so next slide, I do not, well, no, do you guys need to write this down? How good are you at fractions? You might want to write it down if you don't know how to multiply and divide fractions. If you're like, no, I got this, it's fine. But if you can't add and subtract and multiply and divide regular fractions, you're going to be in a world of trouble now because we have fractional equations. So you have to be able to add, subtract, multiply, and divide. Specifically, add, subtract, and multiply. There's not going to be, division's not going to show up a lot on these. But make sure you know how to do this. You must have a like denominator to add. Okay? You do not have to have a common denominator to multiply. Multiplying's much easier. If I've got 3/5 times 1/2, I just multiply straight across. 3/10. Right? But I must have like denominators to add. So if I'm trying to do 3/5 plus 1/2, then I have got to get common denominators. So in this particular case, I need to multiply by 2 on top and bottom here, and 5 on top and bottom here. So I would have 6/10 plus 5/10. When you add fractions, you add the numerators, but you keep the denominator the same. Do not add that denominator. It's not like multiplying. You don't add straight across. I would like to hope that we all know how to do this really well with just numbers right now, since we are all in pre-calculus, but I have taught this long enough to know that that's probably not the case, right? There are probably some of you that still, whenever you see 3/5 plus 1/2, you're like, oh, what do I do? Is this one where I have to cut the common denominators or not? You probably at some point could do it. You just relied on the calculator too much and don't want to do it, on your own. But it's going to be really important because we're getting ready to do some problems, and the denominators aren't going to be 5 and 2, and we can't type them in on the calculator. So we have to be able to understand what the rules are, because we're going to have x's down there that we've got to deal with. Okay. So I'm sure there's some IXLs on adding and subtracting, multiplying and dividing fractions. If you are like, I really don't remember how to do that, that might be something good to go back and look at, because it's important to know those. Alright, so here are our first couple of examples. Give you a second to write those down. Okay, so for our problems here, we cannot solve for a variable if it is in the denominator of a fraction, right? So our goal on all of these problems needs to be to get rid of the variables in the denominator. And we've done a few of these where we've been solving, but we haven't done any where we also had a variable over here as well, I don't think, anyway, so far. So the problem becomes, like, I could multiply by C, but I also have more things over here that I'm dealing with. So the strategy that I teach for these that seems to be most effective is to try to get a common denominator for all of the terms, right? So right now, 4 over C is the only one that even looks like it has a denominator anyway. So this C, I can put it over 1, and the 3, I can put it over 1 as well. So if I want all of those denominators to match, then I would like for all of the denominators to be C, right? Our denominator here is already C. My denominator over here is not, so I need to multiply by C on top and bottom. And over here, I need to multiply by C on top and bottom. So when I do that, C times C is C squared over C minus 4 over C equals 3C over C. And if I want, I could write this on the left-hand side because I have common denominators now. I could write those together. So I've got C squared minus 4 over C equals 3C over C. Now, again, we can't solve for something while it's in the denominator. Now that I've got these common denominators, I could multiply by C on both sides, and it will cancel my denominators out. Or if you think about this, like if the denominators are both C, the only way that those two can be equal to each other is if their numerators are also equal to each other, right? So now my denominators are gone. I've got C squared minus 4 equals 3C. All right, that is a quadratic. How can we solve quadratics? We could use quadratic formula. We could complete the square. We could factor, right? Before we do those, what do we have to do? Move the 3C to the other side. So I'll get C squared minus 3C minus 4 equals 0. If it will factor, and most of these will factor, not all of them, but most of them will factor. Factoring is the quickest. I think this one's going to factor. So C minus 4 and c plus 1 is how that one factors. So I get c equals 4 and c equals negative 1. Now, there is something special about these problems that you need to do that we have to check every time. If I look at my original problem, I need to look at the denominators and look for excluded values. And so for this, we only had one denominator. It was a c. So what is our excluded value? 0. C cannot equal 0. Do either one of my answers equal 0? No, they're fine. So 4 and negative 1 is my answers. It's not that common that you end up getting an answer that is also an excluded value, but it does happen. So I would, you need to check for excluded values every time. Another thing you can think about doing is just thinking about plugging that number back in when you get it to see if it gives you zeros in the denominator. If it does, you would throw that number out. So it would not be an answer. Okay, questions? All right, if we look at the second one, what do we need to use as our common denominator? 6, almost. What else does it need with it? N, 6n. Okay, so if I want to have a common denominator of 6n here, then to change this to 6n, I would need to multiply by 3. So if I multiply by 3 on the bottom, I have to multiply by 3 on the top. To change this one to 6n, I would need to multiply by 2. If I multiply by 2 on the bottom, I must also multiply by 2 on the top. Make sure you put parentheses. You got to multiply the whole numerator by 2. And then for the last one, I need a 6, so I would have to multiply by 6 on top and bottom. So I've got 3 over 6n plus, I'm going to go ahead and distribute here, 12n minus 18 over 6n equals 12 over 6n. Excuse me. Now, I'm going to shortcut this a little bit just to save me some time. Here, if I put these together, they'll both be over 6n. Then I would need to multiply both sides by 6n to get rid of the denominators. So basically, once all your denominators match, you can drop your denominators. So now I've just got 3 plus 12n minus 18 equals 12. Yep, we combine the 3 and the negative 18. We'll get 12n minus 15 equals 12. What do I need to do next? No. Okay, this is just basic solving equations. Add that 15. So 12n equals 27. Divide by 12. Let's just leave it 27 over 12. You will not have a calculator on these problems, so if you have fractions, you can just leave them as fractions. Now, I circled that real quick. I didn't check for excluded values. What was my excluded value for this one? My excluded value was x or n cannot equal 0. That is not my answer, so it's fine. No, there could be many, just like on the homework last night. We just have ones that are a little more simple right now. Okay, questions? You can get by with, you can forget to check the excluded value and it won't change anything as long as one of your answers was not an excluded value. It's fairly rare, but it does happen that those are excluded values. So that's why we want to check them every time. All right, here's your next one. Alright, so looking at this one, what should we use as our common denominator? 6x squared. Okay, so I need to multiply this first one by 3 on top and bottom. I need to multiply the second one by 2 on top and bottom. Make sure you put parentheses around your x plus 2. You have to multiply that entire numerator by 2. What do I do for 1 over 6x? We'll multiply by x. Can you square the top and bottom of a fraction? Like if I have 3/4, is it going to be equal if I square the top and square the bottom? It is not. So whenever you need an extra x, you got to multiply by x, top and bottom. Don't try to like square the top and bottom. It wouldn't work on this anyway because you get 36x squared. But you have to multiply by that x to get that. So, these problems can get long sometimes. So I usually try to shortcut as much as I can. All of those are going to equal 6x squared, correct? Are you guys okay if I just go ahead and do that? Mark them out now instead of writing them on the next step. So I've got 3 equals 2x plus 4 minus x. Okay. I find a lot of times that students sometimes even get the first part right and overcomplicate the end. This is just, if it has a square, it's a quadratic. Move everything to one side. Either factor, quadratic formula, complete the square. If it doesn't have a square, it's just a basic solving equations, right? Just like you do in Math 1 at the very beginning. So you're just combining like terms. 2x minus x is x plus 4, and then subtract that 4. So negative 1 is your x. Is negative 1 an excluded value for this one? No, 0 is the only excluded value. So negative 1 is your answer. Okay, let's try a different one. Alright, so we got 1 minus 2m over m minus 3 equals 1 over m plus 3. This is a Math 3 standard, so like you should have done these problems, I think, last year. Does anybody remember what we need to do for this? What do we need to use for our least common denominator here? M plus 3? How would we get an m plus 3? Like, how would we change this to an m plus 3? Well, that... If I multiply by negative 1, that's going to give me negative m plus 3. Is that the same? Could I do this? Could I do plus 6 plus 6? That'd give me m plus 3, right? Will that work? If I have 1/2, if I do plus 6 on top and plus 6 on bottom, does it still equal what it equaled to begin with? No. You cannot add or subtract from top and bottom. The only thing we can do to top and bottom is multiply. Because when we multiply, we're multiplying by like 3 over 3, so it equals 1. So we can't do either one of those. What do you think, Sophie?
Can you multiply the 2m divided by n minus 3 by n plus 3 and then the other by n minus 3?
Yes, that's what we want to do. So what we're going to have to do on this is our least common denominator. Is going to have to be both m minus 3 and m plus 3. So, and also don't forget this 1 right here, it also has a denominator of 1, but, you know, we could add the 1 right there if we want, but it doesn't change anything, right? So we have to get common denominators for every term. We don't want to leave this 1 out front. We got to deal with it as well. So if I start over here on the right hand side, I've already got the m plus 3. I need the m minus 3. So if I multiply by m minus 3 on the bottom, I multiply by m minus 3 on the top. I can do this because m minus 3 over m minus 3, what does that equal? Yeah, m minus 3 over m minus 3, what I just multiplied by, what's that equal? 1, right? Because anything over itself just equals 1. So I'm not changing the value of this whenever I do that. I can multiply on top and bottom. So if I go over here, I've got m minus 3. This one needs a m plus 3 on top and bottom. So now that these two are good, they both match. They have our least common denominator. What about the 1? I need both right here. So I'm going to have to be multiplying by m minus 3 and m plus 3 both on top and bottom here. Now, do I have common denominators for all 3 of my fractions here? They're all the same, so I'm going to mark them out. That what we're doing essentially is we're multiplying both sides by those, which cancels them all out there. So over here, I've got m minus 3 times m plus 3 minus 2m times m plus 3 equals m minus 3. So if I multiply these together, I get m squared. I get a plus 3 and a minus 3m. Those cancel each other out, and I get a minus 9. So m squared minus 9. When you distribute here, make sure you distribute the negative with that 2m. So we got negative 2m squared minus 6m equals m minus 3. Yeah, we want to combine like terms. So this is going to give us negative m squared minus 6m minus 9 equals m minus 3. What type of equation have we got here? Is this just a regular solving equation, or is this a quadratic? Quadratic. You should end up with one of the two at the end. If you get a cubic, you probably did something wrong. So quadratics, I need to move everything to one side. So if I subtract this m here and add that 3, I got negative m squared minus 7m minus 6 equals 0. Ooh, I do not want to factor with a negative m squared. Okay, I could just multiply everything by negative 1. I could think about this as like moving everything over to the right-hand side, whichever way you want to think about it. But it's much easier to factor if you don't have a negative with your x squared. I could have moved everything to the right-hand side to begin with if I wanted. So I got m squared plus 7m plus 6 equals 0. Right, you're basically just like pulling out a negative and dividing it off, or you could multiply both sides by a -1, or you could think of like just moving all of these terms over here to the right-hand side, which would change their sign to make them positive. So this is a perfectly legal move as long as you change the sign of every term, right? Now, most of these are going to factor. This one does. We got m plus 6, m plus 1. And so we will get answers of m equals -6 and m equals -1. What are our excluded values for this? -3 and 3. That does not equal either one of our answers, so these two would be our answers. Okay, questions? All right, let's try this one. Tell me, what should the least common denominator be for this problem? D plus 5, D minus 1. Remember that 1 right there has a denominator of 1. You need all of them to be D plus 5, D minus 1. So I want you to try this one on your own. check with your neighbor and see if you guys got the same thing. It already has zeros.
Or you can move
You
this up
don't
to the
multiply by
right.
D plus 5. Only multiply it by D minus 2. Right there. So it should be 2
So
and this one already has zeros. So it doesn't get that plus one. It gets D plus 5. It's only this one that gets both.
and then you just add because I was trying 6 and 2. Yeah, and I was like, that's not.
All right, here is what you should get. For this. So you're multiplying the first fraction by D minus 1. You're multiplying the second one by D plus 5. You got to multiply this last one by both because it doesn't have anything in its denominator right now. And so if you distribute your 3 here, you get 3D minus 3. Distribute your 2 here, you get 2D plus 10. Over here, I went ahead and multiplied these together. You can write over to the side if you want, or just do it in your head. D squared plus 4D minus 5. And then this ends up being a quadratic, so you're going to move everything to one side. You should get D squared minus D minus 12. You will factor that into D minus 4, D plus 3, so you will get a positive 4 and a negative 3 as your answers. And neither one of those are excluded. Negative 5 and positive 1 are excluded, so these are your answers. If it was excluded,
Like on the side of equal sign, it was 1 over 1, like 3 over 1, and you had to multiply.
Good question, because that gives people trouble sometimes. So, like, let's say that wasn't a 1 right there; it was a 3. When you're doing 3 times D minus 1, D plus 5, that 3 is only multiplied once. You do not distribute it to like both of these parentheses. The best way to do it, which you guys understand, this is like a side note. This is not actually what you do on this problem. But if there was a 3 there, you would multiply this together like we did and get D squared plus 4D minus 5. Multiply those together first, and then you could distribute your 3D squared plus 12D minus 15 is the way I would suggest that you do it. It is also acceptable to do it this way. You can distribute the 3, but you only distribute it to one of the parentheses. So you would have 3D minus 9 times D plus 5. You can do it that way. And then you would have to do 3D squared plus 15 D minus 9D minus 45. Hold on, what did I do wrong?
You did D minus 3.
Oh, that was a 1. So if that's a 1, that's a 3, and that changes your numbers. But you'll get the same thing there. All right, let's try this one. Copy this one down for me. Oh, sorry. I do that badly. Often. Okay. I will tell you, I'll warn you right now, that if I put this on a quiz or a test, it will be highly missed.
Well,
And it will be highly missed. Not because that denominator is complicated, because I'm going to show you a way to deal with it. It's not hard. The reason this is highly missed is this right here. This negative right here that has more than one term after it. Okay? Everybody's going to miss it. You got to be really careful. Okay? Not because it's super tricky, it's because you're just careless with one thing. So it's not that difficult of a problem. So, I'm trying to warn you, if you see a minus right here, and this will be a real question. I mean, I'm not saying like everybody's going to miss it. I'm saying like 40% or more are going to miss it because, and they'll all get the same answer. There might be a couple kids that just ain't got a clue what they're doing. Then there'll be 60% of the kids getting the right answer. Then there'll be this another like 30% and they're all getting the same wrong answer. And I'll show you what you'll forget to do. So this is not like a bonus problem sort of problem. It's not that difficult. You just have to really be careful when it's a minus instead of a plus right here. Because if you don't pay attention to that, you will forget something. All right. The least common denominator for this. Okay? So, we have two different denominators, k squared plus 5k plus 6 and k plus 3. So, it is possible for this to use k squared plus 5k plus 6 and k plus 3 as your common denominator. However, if you do, I think you're going to get something to the, you might get something to the third power. It's going to be more complicated to solve. So, what we can do is we can factor this denominator before we decide on the least common denominator. And this factors into k plus 2, k plus 3. So does this one. Okay. So we could use just k plus 2 times k plus 3 as our common denominator. Which means that the first fraction already has the common denominator that we need. Second one does as well. All we have to do for this one is multiply this last fraction by k plus 2. So, denominators are all the same. I'm going to cross those out. Alright, I have done this wrong. What did I do wrong? This negative right here goes with the entire numerator. But I'm telling you, that 30% is all going to get the same wrong answer. That's what you're going to do right there. You're just going to write it down like I did. You're going to ignore the fact that that needs to be distributed because it's just that little tiny negative. It happens every time. I try to warn you boldly in notes that it's going to happen. I'm not sure it helps. You still forget. But be careful. You need parentheses right there. That negative has to be distributed. So you should have 3 minus k plus 6 equals k plus 2. Is this one a quadratic or just a regular linear equation? Regular linear equation. So I'm going to combine like terms. Negative k plus 9 equals k plus 2. I need to get the k's together. So I'm going to add this k so I don't have to deal with negatives. So 9 equals 2k plus 2. Subtract that 2. 7 equals 2k. And k is going to equal 7 halves here. Is that an excluded value? No. It's probably maybe Tuesday or Wednesday next week. All right. All right. All right, copy this one down. All right. So we've got 2x over x minus 3 plus 5 over 3 minus x equals 9 over x squared minus x minus 6. First thing I want to do is I want to factor this x squared minus x minus 6. It will factor into x minus 3, x plus 2. And then I need to think about what my least common denominator needs to be. Yeah, so my issue here is I got this 3 minus x. It is possible, it is possible that I could just like list out 3 things, x minus 3, x plus 2, and 3 minus x. But 3 minus x almost matches x minus 3, right? It's like that problem that we looked at on the homework last night. So I could also factor this to make it negative 1 times x minus 3, right? Pulling out that negative 1, again, to make sure everybody follows what I'm doing right there. When you pull out that negative 1, it makes the 3 negative and the x positive, which can be written as x minus 3. So pulling out a negative 1 is going to switch the order. Correct. You're not multiplying by negative 1 here. You're just factoring out that negative 1. So not really, but let's think about what we've got here. I've got 5 over negative 1 times x minus 3. Here's what I would suggest doing. You could go ahead and do negative 5 divided by negative 1, right? And then that would just give you negative 5. I would suggest doing that here. So I'm going to rewrite it so everybody's with me. Otherwise, you can use negative 1 as part of your least common denominator, but the negatives tend to get lost if you do that. So you got, let me clean this up a little bit, 2x over x minus 3 plus, I'm going to take this 5 and divide it by that negative 1 and put the negative 5 on top. And that way I don't have to worry about that negative 1 being in that denominator and being part of my least common denominator. Equals 9 over x minus 3, x plus 2. I also, where this is negative 5, if I wanted to, I could have made it a minus right here instead. If you only have a coefficient, I'd probably just put it here because you're likely to forget to distribute it if you put it over here, and you're less likely to do that if it's here. So if I'm doing this problem like this, now I can just do my least common denominator is x minus 3, x plus 2. So this first fraction needs an x plus 2 on top and bottom. The second one also needs an x plus 2 on top and bottom. The last one does not need anything, so we leave it alone. We okay here? Alright, we'll cancel those denominators. So I have, I'm going to distribute this 2x. So I get 2x squared plus 4x. I'm going to distribute my negative 5. So negative 5x minus 10. And all this equals 9. So this is going to give me 2x squared minus x minus 10 equals 9. I'm going to subtract that 9. 2x squared minus x minus 19 equals 0. Ooh. Does that one factor? I don't know if it does. I don't think it does. Let me see. No, it does not factor. Alright, so, and you'll run into a few of these that do not. If it doesn't factor, what are we going to have to do? Quadratic formula or completing the square. This one's hard to complete the square with because you're going to have fractions. So I just do quadratic formula. So x equals opposite of b, so that's just 1 plus or minus square root b squared minus 4ac all over 2 times 2. I'll probably put ones that you're going to have to use quadratic formula for on the calculator active section. So this test will have, I'm pretty sure this test has like a calculator active and inactive. Or do I let you use calculators on all this? I know I don't let you use Desmos. Because I don't want you typing in one side of the equation and the other side and seeing where they cross. I mean, that's a good check-in mechanism. But I'll have to look at the test and see. It is fine with me if you use the calculator on quadratic formula. So what do we get there? 152. Anybody disagree? I'm going with what Maggie's telling me. Stop me if she's wrong. Oh.
Well, then I'm definitely wrong.
Yes. I know what you probably did wrong. You probably typed in -1 squared without parentheses around your -1. Or, okay. But you might have made it negative there. So, 153. That's a 3. Right there. Let's just fix that. $153. I don't think that'll break down. 9 does go into it. So 1 plus or minus 3 root 17 over 4. Our excluded values are 3 and -2. I don't know what this equals, but I'm sure it's not 3 or -2. Yeah.
What happened if the range was your...
I don't think I put one on the notes like that, but if it were an excluded value, so like, I'm going to go back to the last one just because this one is ridiculous. Like, if 7/2 was one of the was an excluded value, I would throw it out, and since there's no other answers on this one, it would be no solution. If it happened on one like this one, let's say like 4 was excluded, I'd throw it out. -3 would be my only answer. It may happen on your assignment. I'm not sure today. All right, so let me tell you a little bit about your assignment. You got time to maybe do 1 or 2. It's going to be on Delta Math. And it's on Delta Math, but it's different than Delta Math usually is. Because what I have done for this assignment is I have assigned you specific problems. So when you go to Delta Math and look at it, all of them are going to be separate problems, and everybody will have the same question for all of the problems. Okay? So this is more or less just like a worksheet because you guys all have the same problems. I had to set it up as a quiz in Delta Math. So what's going to happen, I think anyway, is that I don't believe it is going to let you take it again if you miss it. So what I want you to do for homework tonight is just write your work out like you normally would for homework. Okay, so number it and write it out. You do not have to make a 100 to get a 100 for the problems, but I will ask to see your work tomorrow. Okay, so because if you miss it, it's not going to give you a second chance on it. It will show you what you did wrong here. Now this one's super simple. I didn't do one like this. This could go all the way back. You could do common denominators, but what could you do on this one? You could cross multiply and get 7x equals 84 and divide by 7. You can only cross multiply if it's just one fraction equal to the other fraction, but you could do that there. Yeah, please type your answers in because that tells you if you got it right or not. And that way you can see if you missed it. So it sort of helps you check as you go. But please write down your work for these. I don't think there's anybody that can do all of these. I do not believe that any of you can do all of these in your head. If you say you can, I need to. If you skip that one, that's okay. Yeah, 12. Yes. Yeah, so 12 is that first answer. So if you don't want to write that one down, that's okay. But then write the others. You could, yeah. Yeah. I think you just type the 12. You like writing them handwritten? I don't like to do it when there's a lot to write because it really slows us down. But whenever it's just the problems, it's not bad.